Hello and welcome, I'm Thomas and this is day 14 of 100 Days of Code in IoT Challenge. Today I'm just going to continue working on a project of changing the time control relay device based on ESP8266 to be temperature controlled instead. So I can use it to control a simple electric heater. Yesterday I finished on the lambda function behind the API gateway and I tested the endpoint with the temperature. It returned 24. And I pasted the URL as a comment to the main CPP file. So I'm gonna continue from this point. Okay, so yeah, I've got the diagram here because we're mainly gonna be working with this at this moment. However, yeah, what I'm gonna have to start with is to include the temperature sensor library. So in order to do that quickly, I'm going to open a new window. And in this window, the new window of Visual Studio Code, basically. And in this window, I'm going to go back to the temperature sensor project. And in the temperature sensor project, I'm going to copy this code and then paste it here as a comment for now. And then move it around. So the include, that's gonna go on the top. Creating an instance of DHT right after Wi-Fi manager. Then the setup. That is going to my setup right after digital, right? Small change in here, which is going to be the pin number, but we're going to make it clean like we've done with other pins. So this is gonna be time, sorry, it's not time, it's temp sensor pin, and that is D6. This is where the sensor is connected to, the middle pin of DHT11. Right, okay, so setup is done. And then what is left is the stuff in the loop function. But yeah, I'm gonna do it in a second. First of all, I have to look at send HTTP request, right? Send HTTP request, according to the diagram, needs this safety mechanism. So I'm thinking about making another class. And you know what? It is called APIGatewayClient. Here I'm gonna just be consistent with the diagram, but this is not the best name. Client. It should be more meaningful, describing what this piece of functionality does. But it's fine for now. Okay, so send HTTP request, that is get temperature. Right. You know what? This I have to change because get temperature it indicates that it returns something. But it doesn't really, so low temperature. I think it would be better name. So got low temperature. And for the safety mechanism, we're gonna need a class variable. And this is going to be for in progress. So yeah, just request in progress, I think is the best name. Request in progress. And that is false. As a default value, this is gonna be false. Okay. Now, when we load the temperature, this is when we want to make sure that request is not in progress. I mean, if it's in progress, we return. So this is not gonna be executed. Otherwise, what you want to do is to immediately change this flag to true, right? So if it's called right after that, it won't be, this part won't be executed until this is done. So Wi-Fi manager disconnected. Yeah, I guess you may ask why I'm gonna keep connecting and disconnecting to Wi-Fi. The reason is, right after we finish the first version of the software, I'm going to add set interval function. So this is gonna happen, not, it's not going to be continuous, right? So once the request is done, it's gonna do another one and another one after that. I'm going to put some time between those requests, some interval. I'm gonna put them as interval, but there's gonna be the second version right after this one. Okay, the next change is going to be the endpoint. So the endpoint is now this. So I'm gonna paste it here. Yeah, the hello is not required really. Okay. And this is get. This is HTTP get. There's no body. It is get everywhere. Get unable to connect. Okay. There is no get in here. And for the payload, this is going to be, at this point we've got it as an integer, but ideally we would like this to be float. So the payload, which is a string, as this is returned from HTTP, or maybe actually there is something on HTTP we could do as getStream. There is only getStream. Okay, so yeah, we have to live with getString. We're gonna have to transform that string into a float type. We're gonna operate on the float type because essentially the temperature sensor operates on this type. Right, and two variables. 1 second though. Yeah, the EventDispatcher needs to become a dependency. That's another thing. According to the diagram again, we would like to dispatch temperature received. And that is going to be here after the conversion to float. So we need a constructor where we take a dispatcher. Okay, we've got the dispatcher, and now at this point, dispatcher is going to dispatch an event. We also need to define this event. So that's gonna be the static const expression. The API Gateway Client name implies that this is something more generic than getting the temperature. So I'm thinking about putting a temperature here. So let's call it API Gateway Temperature Client. I need to think a little bit about the good naming. That is one of the greatest problems of developers, to name things, right? Okay, so this is going to be, I would like to keep the convention of this event naming. So yeah, that starts from from the uppercase, so we have capital letter. I'm going to call it temperature received event. And this is exactly the event that is going to be dispatched. Yeah, at the moment, we cannot really provide here the actual temperature. So I'm going to modify EventDispatcher. So here we need to have a way to pass another parameter, but also I would like to keep EventDispatcher as generic as possible. So ideally I would be able to pass any type, which is not easy in C++. And the way I could do that is with the use of generics, aka templates. So let me show you how this can be done. Event type. First of all, because at the moment the functionality is very limited, right? It's just about dispatching the event name and then calling all the listeners subscribe to this event name. What I would like to do is to be able to pass some sort of metadata about the event to all of the listeners, right? And the way I'm thinking about doing it is to turn this event name into a struct that I call event, right? So I can give you an example just quickly how the temperature received event would look like. So we have something like struct temperature received event, and then on the struct we can define whatever we want, right? So that's much easier than allowing maybe for passing multiple parameters here or something like that, right? So let me just turn this into event type, and it'll be event. All right, so that's one thing. However, now we've lost event name. We don't have event name. In C++, there is a way to get the name of the type with type ID. However, it is not really possible with the current configuration. If I do that at this point, it's going to fail, regardless of what I pass. Like if I say event, or if I do event, doesn't really matter, because let me just show you. If I compile, this is gonna complain about no RTTI flag. So that's the flag that you use with the compiler to make the type ID getting the type names possible. Right, we don't really have access to it on embedded environment. I guess I could change it somehow, but there is a reason why this is not used, right? In the limited memory environment, I guess maybe these are the reasons. Anyway, there is other way to do that. I could enforce a static C string on the event, right? So I could do something like that. I could do something like that. Event type name, maybe capital N. And if I do that, it's going to require the generic type that is passed here to be to basically have the static member called name, right? I can try to compile, but now it's going to complain about something, about this name thing, because it is used in main CPP and is not used in this way, right? But before I fix this main CPP, I need to modify other methods here as well, because having event type as a generic type here forces me to do the same thing for the on and once. And the reason is simply being able to pass this metadata to the listener, right? Because at the moment that would just be the dispatching thing, right? So that just iterates over the listeners and looking for the listener with the event name that is the same as the past event name. So the event, and you want to pass it to all the listeners. So this callback ideally would be called with the event. Just a pointer to the event because we want to save memory. We don't want to copy it to every single listener that listens to this particular event. So just an address, just a pointer, right? Okay, but that changes the way these on and ones work, right? Because we need to be able to take this also with the generic. Right, we want the listener to receive an argument, and that argument would be the event type pointer. Perfect. This is not all though, because just a quick one. So the event name doesn't exist. I mean, we could still force the developer to pass event name, but there is not really a point since the generic is already the generic type is already being passed here. So we could do the same thing I've done here. We could do here, and that makes event name redundant. So I'm gonna remove it. Not required anymore, right? Okay. And right, I could try to compile it. It's probably going to complain about main CPP mainly. But there is another complaint, which is a no match for call to std function void and nothing inside. The reason is that it doesn't accept an argument because the way I defined the vector is with the listener, and the listener has a callback member that returns void and takes void. So that would have to take a generic type as well. The problem here is it is not really possible. As far as all the research I have done on this subject, there's not really a way to create a new member specifically for the type every time the new event type, new generic type is introduced, right? Because if I wanted for this to enforce a certain type, right? Whenever you define a listener for the event that the class EventDispatcher doesn't have a member yet, you would have to create it somehow, right? And I mean, putting it on another vector, it's still not possible because that vector takes a generic type. So you would have to provide the type, but you don't know what this type is going to be. So, this is like, what I ended up trying to discover it. But there is other way. Which is a void pointer. The void pointer allows you to cast any pointer to it, right? So this is like any type for the pointer. The only thing is, when you want to cast it back to the original type, you need to know what the type was when it was casted to void pointer, right? But I can have this information because if I enforce a name as a static here, I'm just gonna show you. If you have a name here, temp, received whatever. So as long as this is unique, we will have the way to do that, right? Because when you set the listener here with the generic type, I can cast this to the whole std function. I can actually provide another function that calls this function that takes void and casts the void into event type, right? So this is where it is cast from void pointer to the original type. And that would be the place where the event here is cast to void pointer, right? So this address would be cast to void pointer at the moment this is dispatched, and all the listeners said before, they would take the void pointer, right, and cast it to the original type pointer, and that would be passed to the callback, to this callback in here. So it is a bit like in reverse. So what I'm gonna do here, what I'm gonna have to do is to pass a callback here that takes a void pointer, and inside it calls the past callback, right? But with casting it to the event type. And exactly the same thing needs to happen for once. Right? And that makes the event dispatcher complete and generic. You could ask, what if I used the generic type on the whole event dispatcher? I could just use the template on the whole thing instead. But that's gonna make me create a new instance of event dispatcher for any event type, right? Any new type I introduce, I need a new instance for event dispatcher. So that would complicate the code from the consumer perspective. So I'm sticking to what I've got here. If you know the better way of doing it, because I've spent on this a lot of time already, if you know better way to do it clean with the types, let me know in the comments. I would be very keen to find out about better solution, right? Because, using the void pointer is not very safe. I mean, it's not very dangerous in my case. It is a little, but it's not very dangerous as long as I keep the event names unique, right? That enforces having a name on event. So as long as I keep them unique, that's gonna work, right? Because this is the moment where this is cast to a void pointer, and when this is executed, this is the moment when it's cast back to the original event type, right? So this is happen. It happens essentially internally in the event dispatcher, right? But yeah, enough for the event dispatcher. I'm gonna do a quick compilation. It's gonna fail, yeah. And what I'm gonna have to do is to modify main CPP for the whole thing to work. So first of all, these events, they have to change. I'm gonna go to Wi-Fi manager. That needs to be turned into a struct. So we'll have Wi-Fi connected event, one struct, and another struct is gonna be Wi-Fi disconnected event. And both of them need to have a name. So I'm just gonna rename this for name. I guess later on I could create some sort of macro in C++ to make sure the name of the events are truly unique. Right, so that's one thing. And another thing is going to be for another change is to this event. So we'll have another one, and that's just gonna be changed to name. I have just realized that the constructor is incorrect and that this is supposed to use the dispatcher that has been passed as a pointer to this class. Okay, and at the same time I can actually fix this one, because since this one doesn't require two arguments now, but just one, and the generic type, and also generic type being an argument here, which we don't really need to read, so I'm just gonna do that. And the same thing needs to happen for for the other ones. But let's just fix this one, because that needs to be a struct now. I'm gonna add the temperature in a second. Okay, and setup function. So setup function, again, on this is going here, and this is going here. Same for dispatcher ones. This is going here, and this is going here, and that is not required. Right, and for this one, disconnected, again, generic type, and this is obviously required. I can do some overloading later on, so if we don't need that, we could just pass the void still. Okay, so saving this, compiling this. Right, still a few things to have a look at. Yeah, this is one thing. I'm going to comment it out for now. And probably something still missing, which is in Wi-Fi manager. Yeah, so dispatching this one, again, that needs to be passed as a struct. Right. And now I should compile this. And this works. Okay, so that is done. Okay, let's pass the temperature now. So I'm going to add a float temperature to the struct, and when this is dispatched, I'm gonna need to read this payload. So I'm gonna have to cast it. And to convert the string to float, I'm gonna use str. I can actually do it straight away here. So that would be strtod function that takes a C string, const char, and the second needs to be null. And that should actually pass the temperature as a float. There is some, from now in conversion from double to float inside. Yeah, I got a warning, the reason is because, that returns a double. So I could do something like, let's say, double temperature, and that's gonna be this. And I think if I intentionally cast it to float, it should not complain anymore. I mean, it's just a warning. I could skip it, but I don't like warnings. Okay, so yeah, that makes it working. And the next step, it's going to be essentially to implement this diagram, right? So we got our API gateway client. The way the API gateway client works is implemented already with the request in progress flag. And we also dispatch temperature received event. What we need is to have this listener and those two global variables. And now obviously the logic to switch the relay on and off with the conditional statement on the sensor and desired temperature. So yeah, first of all, I'm going to, somewhere here, I'm going to define float desired temperature and float actual sensor temperature, let's say sensor temperature. Right. And as a default values, we actually want the desired temperature to be higher than the sensor temperature. So I'm gonna say this is 20, but the sensor temperature is 25. These are default values. I can get rid of them later on once we make everything non-blocking. But right now, since the getting the temperature is blocking, I'm gonna have to do it in a blocking way. Okay, we need an instance of the API Gateway Temperature Client, but to be honest, this can be easily extracted first. So let's create the HPP file and paste the whole thing. I mean, cut and paste, right? I'm gonna move the whole thing here. That needs to be pragma once. And that requires EventDispatcher. And I think EventDispatcher is the only one that, oh yeah, there's also HTTP client. It's not the only one. It needs a Wi-Fi manager as well. Wi-Fi manager. Right, and that is not everything. HTTP client is also required. So HTTP client. And I think this is it. Yeah. So what I'm going to do now is to include API Gateway Temperature Client, and I'm going to have to create an instance of it. So that's going to be API Gateway Temperature Client, and let's call it Temperature Client, and that takes, I think that takes only EventDispatcher. So that's going to be dispatcher only. Let me just confirm this, but yeah, that's just dispatcher. Right. Okay. We have desired and sensor temperature here. And then in the setup function, what I would like to do is to in the setup function, I can actually set the listeners. So we'll have dispatcher 1 on, and the event type is going to be API Gateway Temperature Client temperature received. When we get this, I'm gonna pass a callback. And this time, this is gonna take the E as an event argument. Let me save this so you can see everything. Yeah. And when this happens, what I'm going to do is to set the desired temperature. Is it desired? Yeah, that should be desired temperature. And I'm going to set it to E temperature. Right, so that is this listener on temperature received. That's what happens. Okay, and now to the loop function. And in the loop function, we need the temperature client to be called low temperature. And what else we need? There's not going to be button. I need to remove the button from the breadboard. This is all not really required. Let's just start again. So what I need is a delay with the DHT sampling period, and we need to get the temperature. And this temperature is going to be sensor temperature, and sensor temperature equals get temperature. Let me just quickly have a look here again. You know, sensor temperature doesn't need to be global, because we're going to get this information. Since this is blocking, we have to do it at every single call of this loop function. It doesn't have to be like that, right? So that is, we can make sure the sensor temperature is actually always up to date. We don't need to set any variable here. So that can even be in a scope of loop function only. Right, so that is one thing. And then if desired temperature is less than sensor temperature, if the sensor temperature, is it how it works? Yeah, if sensor temperature is less than desired temperature, we want to switch the relay on. Switch on the relay. And else, we want to switch off the relay. Right? And this is it. That implements this whole diagram. I don't need humidity here, so I can remove that. However, two more things before I deploy this. So first one, I would like to print some information about the desired temperature and sensor temperature. So desired temperature, that is going to be, and sensor temperature, that is also going to be something like that. And quickly, desired temperature, sensor temperature, desired temperature, sensor temperature. Quickly compile this. Oh, one more thing with the API gateway temperature, which is the Wi-Fi manager that we don't have access to. So what I could do is to take Wi-Fi manager in the constructor. Yeah, I wonder why this issue didn't appear before. But yeah, that's quick one. And the certificate as well. So for the certificate, I'm not gonna bother. So just gonna move it. So yeah, that's certificate, and now Wi-Fi manager is a dependency on the API gateway. Right. Okay, done. Right, so we got this printed out, everything compiles. I'm also thinking about adding some additional temperature range. So we won't have a situation where, like, let's say we have desired temperature 21 and the sensor temperature is 20. And then, so the heater is switched on, temperature increases, and then, desired stays 21 and sensor temperature reaches 21, right? It switches then it switches off the heater, and now the temperature is going down. So desired stays 21 and sensor goes to 20.9. So the heater is switched on again, right? And at the time to reach 21, it's gonna be quick, right? So it might be, 1 minute or something. And then again, we're gonna have the situation where we have 21. So it's off, right? And that thing is gonna continue on and on. So to limit the number of switches on the relay, it would be nice to add some range. on the temperature, right? So desired temperature can stay as it is, but I'm thinking about half a degree, so like quarter a degree before the desired temperature and quarter degree after desired temperature. That will be the range, right? So between desired temperature minus quarter to T plus 0.25, right? So I'm gonna define a variable T, and that's gonna be 0.25, and modify this if statement a little bit. So instead of one if statement, we're gonna have two if statements, and they're essentially gonna be like that. So if the sensor temperature is less than desired temperature plus 0.25, which is T, right? Then we switch on the relay. And if a sensor temperature is greater than desired temperature, that should be minus T, and that should be plus T. Okay? So let's say it's 21 as an example. This is 21. So it's going to start at 20.75, right? So any temperature below 20.75. And to switch off the relay, we're going to have 21.25, right? So this is the moment where it switches off. Anything between, it's gonna keep its state, right? Either on or off, depending whether the temperature is actually increasing because the heater is on, or it's decreasing because the heater is off. Okay, so that's it. The diagram implemented, everything implemented, code refactored. I'm gonna deploy now. Okay, deployed, and a serial monitor. We can see the time being synchronized. Again, that takes some, yeah, okay. So now we got it. Right. So yeah, as you can see, now the relay is switched on because the temperature has been retrieved from API Gateway. Okay, and now just gonna continue. Let me reset it. So that worked again after the restart, right at the beginning, because the desired temperature, the default one is 20, and my temperature in my room is 21.8. It was switched off. The relay was switched off, right? But right after it's downloaded 24 from API Gateway, it's switched the relay on. There is no heater connected yet, but yeah, I'm just gonna do it. Let's see what happens, right? Maybe good idea is to modify it slightly. I mean, the desired temperature. Maybe I could do it 22.5. Maybe that's better. 22.5. That's what I'm gonna do. So quickly to the, not this one. I need the temperature. Not the temperature, hello from IoT, because the value is hard-coded, as you remember, right? Let's make it 22.5, so it's going to be easier for the heater to increase the temperature in my room. Come on, all those, yeah, and make deploy. So it's going to be hard-coded to 22.5 now. Okay, while this is deploying, I'm just going to connect the heater to the cable, right? And then to the socket. So yeah, let's do it now. Okay, so I need to connect AC adapter here. So the relay has 5 volts. Then, yeah, everything's connected. You know, the stuff like button and buzzer, we don't really need. So I'm gonna just quickly disconnect them, so they're not gonna be taking space on the board and not confuse anyone here. So yeah, that is not required, and this is also not required. Okay, so now it's just the temperature sensor and the relay, which is here. Yeah, but I'm gonna zoom out in a second. I'm gonna show you. Right. Okay. Because we want to supply some power. Yeah, this is not required anymore as well, because we want to supply the 3.3 to the board from USB. This is important so we can get the readings on the serial monitor. However, we still need this power supply module because we need 5 volts to be supplied to the relay module. Just one more thing before I switch it on. This one wire is also not required. That was for the button. So now it's much more clear, right? So we have the temperature sensor and the relay only. Okay. There is one more thing I have to do, because since we're drawing 3.3 from the USB and 5 from the relay module, we're gonna need to connect the grounds for the relay to work. So what I'm gonna do is to connect the ground of ESP to the ground of 5 volts. So the relay can be actually controlled. Otherwise, if the grounds are not common, that wouldn't work. And now to the final stage. So first of all, I'm gonna keep this switched on, half power. Then, the second step, it's going to be connect this, right, the heater here. Right, so heater is connected. Now we need to connect it to the power socket. So I've got this one here. So connecting it. Right. So the high voltage circuit is ready. It is connected now. And what I need to do next is to connect the low voltage circuit. And the low voltage circuit, or maybe before I do that, let me switch on the power supply. So we have power supplied to the relay module now. The last thing is to connect USB to my computer and then connect to the serial monitor. Okay, let's see. Connecting USB and the serial monitor. Okay, relay is off now. Okay. Right, because the temperature in my room is not 22.5. It was 21.6. Now it's 21.8. So heater is on. I'm gonna move it a little bit to heat the air near the temperature sensor, and we should quickly get this switched off once this reaches the temperature of 22.5. Okay, that was quicker than I thought. But yeah, obviously, if I wanted to heat my room, I wouldn't place the heater right next to the board. That's gonna take some time until it goes down to below 22.5. $22.7. It needs to go below 22.25 for the heater to start again. Maybe I actually move it a little bit so it's not going to blow straight on the temperature sensor. So we're gonna have a little bit more time until the temperature on the sensor increases. Okay, so it dropped below. The heater is on again. Okay, I think this is enough for demonstration. So we have our relay device temperature controlled now, and this is working very well. I can improve it further, that I'm gonna do tomorrow on the Lambda side, because, you know, I'm thinking at least having a file where I can define different hours and different temperatures, right? So like, you know, at night having a different temperature than during the day. So that would be one thing. And another thing, on ESP8266 side, there is still a room for refactoring the code. And also something I've already mentioned, which is not constantly making the request on the to the API gateway, but having an interval, like every 15 minutes, let's say, I want to make a request. So I'm gonna have to introduce a timer class. But yeah, that all of this tomorrow. This is gonna be the last day on this project, so it's gonna be more like a refactoring session, quite long. Also as today's video. And yeah, that's it. Thank you very much for watching. If you like the video, you like my content, and you don't want to miss the next one, subscribe to my channel. If you have any suggestions for the future projects or a question, let me know in the comments. And yeah, cheers, bye.